Welcome to tecversity. This is Venkatesh Natraj. Hope you all are doing great. Today I'm going to talk about networking. Networking is our daily routine. Be it our favorite song on Spotify or favorite show on OTT or just a YouTube scroll. We are using network as our backbone. How exactly this entire system works in networks? Since network is a vast topic, I'm going to break it into multiple modules. In this video, I'm going to purely cover on the basics and the basic devices that are used in networking. With no delay, let's jump into the networking. Before that, if you haven't subscribed to tecversity, please make sure you subscribe it and share this video with your friends and family. Networking, let's try to understand the basics of network. So what types of network we have and what devices used at each level. So to start with, there are three types of networks. One is LAN, which is a local area network. The other one is MAN, which is a Metropolitan Area Network. And the other one is WAN, which is Wide Area Network. So this is at a very basic level. Now when we talk about the LAN, the device that we generally use at a LAN could be a hub. And at a MAN, it will be around a switch or a router. And when it comes to WAN, definitely we need a router. So I'll talk about individually what exactly the LAN is about and what is a hub, what is a MAN, what is a switch router, and about WAN and router. To start with the LAN, we'll try to understand what is the peer-to-peer network and how is different from other networks. So I have computer 1 and I have computer 2. Now to keep these two computers in network, I can give one connection directly with using a CAT cable or a network cable and all I need is this computer should have an NIC, which is network interface card, and an IP address. Similarly, I need an NIC here and an IP address, and I have to keep this both IP addresses in same range. I'll explain in little about what exactly the IP and what is the same range is about. For now, think we need an NIC, that is a network interface card, and a IP address. Now in this, it's pretty straightforward. There is nothing like we have only two computers and we are both connecting together, and this computer can talk to this and this computer can talk to this. What if I have more than two, like if I have 3 computers or 4 computers? Then there is a challenge because we cannot have a straight connection. The connection there should be a centralized point and it should communicate through the centralized point. So let's try to understand what is that centralized. So I'm talking at a very basic level. I'll take an example of 4 computers. It's C1, C2, C3, C4. That means computer 1, 2, 3, 4. Now all these computers needs to be connected, right? So I will install a device called hub in the center where all these connections will come to hub. Now hub is a device which will initiate the connection and it will ensure the connection establishes from one computer to computer other. For example, if C1 wants to talk to C4, it can communicate, and C4 wants to talk to C2, or C3 wants to talk to C1. So it is easily possible when there is a device which enables the network between the computers, and that's called hub. Now how exactly hub works is, now when I say every computer needs an NIC card, network interface card, and an IP address, NIC is a physical device that installed on the computer. That means we will plug the network cable to that computer. So to insert that we need NIC card, that is network interface cable. Or if you think we can install a Wi-Fi and without a connection, even in that case, to enable the Wi-Fi, to read the Wi-Fi, it needs a Wi-Fi enabled NIC card, and it should be able to understand okay, what are the available networks, and it will try to connect to that particular network. So it's the same, only difference is here it operates through cables, and in other case it will operate through wireless networks. How exactly hub works is, hub will have no memory. So how exactly it works is, now when C1 tries to communicate to C4, the data will be broadcasted. That means hub will send it. It doesn't know which is C1, which is C2, which is C3. Hub doesn't have that memory. So what it will do is, it will transmit the data. It will, once the C1 is trying to communicate with C4 or C2, it will broadcast that data saying that, hey, I have some request to C3. Are you C1? Are you C2? Are you C3? So it will try to reach to each computer, and it will make sure that connection is established once it identifies the specific computer. Now in this case, now C1 want to talk to C3. So that data will be, it will reach from C1, it will reach to hub, and hub will broadcast that to C2, C3, C4. And once C2 or C3, once C3 accepts it, then there will be a temporary connection established from C1 to C3, and it says that connection will be available till the data transfer. Once the data transfer is done, gone. That means it will not recollect which PC is what and which connection needs to go to which computer. So hub is a very basic device to communicate, and it operates at a LAN. Like I said, LAN is a local area network which is within a building or a 2-story building. That's it. Max you can communicate or you can connect within the LAN is hardly 25 devices. Even hub will have max 4 or 8 or 12 ports. That means max we can connect, the basic devices will have either 4 ports or 8 ports or 12 ports. That's the maximum availability within the hubs. Mostly hubs are obsolete now, mostly people are not using. So but it's a good to know information about the hub. Hub is not an intelligent device. It will just enable the connection, and it will broadcast, and after the broadcasting it will identify which computer want to talk to it, and it will enable the connection. And once the data transmit is done, that connection is disappear. It's a temporary, remember, it will not have any specific memory. So let's move to the next device called switch. Now switch, it's a special device. It's also known as an intelligent device. I'll explain why. So I have the same example. I have C1, C2, C3, C4, and there is a switch in between. Now what is different from hub to switch is, all these are connected again here to switch device. Now the difference is, like I said, every computer will have a NIC card, NIC card and IP address. So all systems will have this NIC and IP. Now every NIC card, when there is a NIC present, that means a network interface card is present in the computer, means that network interface card will also have a physical address. That physical address is known as MAC. That means media access control. MAC address. So this MAC address means it is a physical address of that particular computer. Now when we install the NIC, that means a network interface card in a computer, that will have a physical address, and that is a 48-bit address. I will explain what is a 48-bit, what is IP, what is 32-bit, what is MAC. I will give everything in detail in the going forward videos, but for now try to understand. Every computer will have an NIC card, and that NIC card will have a address, and that address is called as MAC address. MAC means media access control. That's the full form of MAC. Now what switch does here different is, when we have the connection established, now every PC will have one MAC address since it has a NIC card. Now every PC also have IP address. IP is also called as a logical address. So every computer will have two addresses. One is a physical address, other one is logical address. So now when C1 wants to talk to C4, example, in this case what happens is, the C1 sends the data to switch. Switch will think, okay, I received data from C1. Now it will send the like hub, it will transmit the data to all the PCs, saying that hey, I received a data from C1, it want to communicate to C4, are you C4, are you C4, it will send that broadcasting data to C2, C3 and C4. And once C4 accepts, hey, I am C4 and I want to I'm ready to accept the connection, then what happens is the hub will have a table. It will have a table. It says, okay, port 1, this is the IP address and this is the MAC address and this is the computer name. Similarly, now C1 has already sent, so it will register, okay, the port 1 is connected to IP, this is the IP, this is the MAC and this is the computer name. And C4 is accepted, right? So it will maintain a record. It will maintain a record within, it will maintain a MAC address table. In that address table, it will have IP address, it will have MAC address, it will have the computer name. Now why this is required is, once this connection is established, this record is permanently recorded here. And whenever the C1 want to talk to C4, it will not do the broadcasting. Instead, it will enable the connection from the port it has connected to. So every PC is connected through the port here. Now it will directly connect here and it will enable that connection straight from C1 to C4. Similarly, from C2 to C3. So whatever the computer IP address, whatever the MAC address, the switch will understand that and it will maintain a record and it will not do the broadcasting. For the first time, it will do the broadcasting to understand which PC has what IP address, which PC has what MAC address and what is the names. After that, it will not do that broadcasting anymore. It will enable that connection straight from computer 1 to computer 2, computer 2 to computer 3, whatever the connection and how exactly the users want to connect. So that's the switch. Now switch is primarily used in either LAN or MAN. Now switch will have multiple ports. Now switch will have 8 ports, 16 ports, 32 ports. So since it can operate, it can communicate with 32 machines at a time and it can maintain a record. There are advanced switches that recently has come which has even 64 ports. Now we understand the difference between hub and switch, right? So let's try to understand what is a router. So I'll do the same example. Let me erase this and I will give the same example how exactly the router is. Now I have 4 computers and I have a hub or a switch. All these are connected here and I have another office or another connection which has the same. So it is also having a switch. Now the difference here is this IP address range. I will talk about the IP addresses in detail. What is IP address? Why we have different classes? What is the differences between class A, class B, class C? What is the subnet mask? All this I will be talking in the upcoming video. But for now, think there is an IP and that IP should match the network ID. That means every IP address will have a network ID. And if the network ID matches, that means if both the IPs that they want to talk, if they are in the same IP range or the same network ID, without a router it can communicate. If it is a different network, it needs a router. So I know it's slightly confusing, but I will explain. I'll try to explain it in a very short form. So here I have C1, C2, C3, C4 and a different network C5, C6, C7, C8. Now this C1 want to talk to C7. It is not possible because this network is different and this network is different. So to communicate outside the network or simple, we are trying to connect to internet, right? So internet is completely, we have all the systems connected, but each one have their own IP address and it has a different, right? Your system is also in the internet, my system is also internet. To communicate that, we need a router. So we will have a router installed here and that router will enable interconnection devices. That means a router will enable 2 different networks to talk together. Have a different network, you have a different network, and together they have to talk to each other. Is there should be a router installed, and that router should be able to identify which PC they even want to communicate, and it will ensure the network is transferred here. Now there is another concept called OSI, that means Open Systems Interconnect, OSI, which has 7 layers of data will be transferred through these 7 layers. I will have a separate, completely a dedicated video for OSI layers, how exactly the data will be transferred between these 7 layers and how it will reach from the source to the destination. So it's a very exciting topic. So for now, try to understand that there is a hub which will not have any memory. It will enable the connections, and every time it will try to broadcast the connection, broadcast the information, and enables that communication between two computers. Whereas a switch will, first time it will do the broadcasting, and whenever it comes to come across a new machine, it will update its records, and it will keep that table updated, like which is the MAC address, which is the IP address, and whenever it receives a request, it will try to connect to that PC. Third one is a router. A router is about from PC between two different networks. If it has to communicate and to transfer the data, a router is required. For example, a router is in our home, like we have a routers at our home for internet access, because internet access, with the internet, when we are talking, it is completely we are connecting to the outside world, which is from internal, from our home we are trying to connect to outside. So that's the reason the router will enable you to connect to the internet, and the two different networks here working together to ensure your data, or you are able to access whatever the websites or the data that you want to transfer. So pretty much this is about today's class. I don't know whether it makes complete sense, but I will show in on the PC in the next video how exactly this entire connections will happen. But for now, try to understand the difference between the hub, switch, and router. In case if you have any questions, please feel free to drop a comment. I would be more happy to help on that, and let's connect on the next session on the IP addresses and OSI model. Have a good day.